let's look at vectors. Now, an object with both magnitude and direction is what is called a vector. In other words, anything which has magnitude and direction is known as a vector quantity. Magnitude is the size. Anything which has size and direction is what we call a vector quantity. And a vector describes the movement from one point to another. In order to understand vectors, let's first look at the meaning of a translation. A translation moves a shape from one position to another, but it does not change its appearance. Every point in the shape will be translated in the same direction and by the same distance. So in other words, a translation can move a given shape, maybe a rectangle, from one position to another. Take an example of maybe I have this. So I could have my my shape there, and then after a translation the same shape is taken here. So in this case we say that this figure has been translated from this position A to this position B. But if it has undergone a translation, then its shape must remain the same and its appearance must remain the same. It's just that the figure itself has changed position due to a given translation. So when we translate something, it will change its position, but it will not change its appearance. Let's look at just one example about translation of figures. A is the point 3, -1, B 7, -5, and C -2, 2. And these are vertices of a triangle. Then if the triangle is translated using the vector -4, 5, determine the vertices of the image. So we're translating this triangle from one position to another using this vector. So this vector here is called a translation vector. And I want to determine the coordinates of the vertices. So to get the coordinates of A, we shall get the original point, which was 3, -1, add it to the translation vector, which is the one translating 4, 5. It's the one moving. We get -1, 4, meaning the coordinates of that image for A, I'll write it like this, will be -1, 4. Likewise, we do the same for this vertex B, this point B, which will be 7, -5, plus the translation matrix, translation vector, which is -4, 5. We shall get, this is 3, and then this is 0. So the coordinates of B for the image will be 3, 0. Then finally C, we shall have the coordinates of C, -2, 2, plus the translation vector, it's negative 4, 5, and this gives us negative 6, 3. So the coordinates of the image for point C will be negative 6, 3. So if I wanted to represent this graphically, then I'll plot this triangle ABC, and I also plot this one, A prime, B prime, C prime. Then I'll have a situation like this. Then I'll see where the triangle has been translated to. We shall look at translation more in details in further topics. So let's look at something else. Now, the knowledge of translations is very important in understanding congruence of figures or similarity of figures. So if a figure is transformed into another by translations, then we say that the two figures are congruent. Like here, this figure A and figure B the two are congruent or similar because they've been transformed by the translation. We say those figures are congruent, and congruent figures must have the same size and shape. We shall also look at congruence and similarity in topics that are to come later on. Let's now understand how a vector can be represented. The representation of vectors. Now, a vector can be represented by a line segment labeled with an arrow. An arrow which will be indicating the direction. So for example, if I have this and then I have starting here at A and ending here at B, then if I put an arrow, then this is a vector. This is a vector AB moving from A to B. So the direction is from A to B. And this one can be written as A, B. We could even underline, or we could put an arrow, and the arrow will be showing the direction of the vector. So the arrow shows the direction of the vector. The arrow shows the direction of the vector. So this vector is coming from A towards B. Another way of representing vectors is to bold. We could just call this like vector small a and then bold it. There are so many ways of writing vectors. Okay, so that's how we write and represent vectors. Now this point A will be called, this one will be called the initial point. Initial point of the vector, which is also known as the tail So this is the tail of the vector. Then point B will be known as the final point, terminal point. Sometimes called the head of the vector. So this vector AB has A as the tail and then B as the head. That explains why vector AB is not equal to vector BA. They're not equal because when you look at AB, the head is at B and the tail is at A. Then when you look at BA, the head is at A and the tail is at B. That means those vectors are different. In this case, they'll be opposite. A and B, AB and BA will be said to be opposite vectors. So the length also of AB, this line segment AB, will represent the magnitude or size of this vector. So the length of line segment AB represents the size or magnitude of vector AB. We said we could underline, we put an arrow to show that this vector is coming from A to B. Okay, now vectors can also be written in column form. If I have, you can note that vectors can also be written in column form. For example, vector A could be given as that. This one up, XC, represents the horizontal displacement. How far the displacement has occurred in the horizontal direction. Then Y represents the displacement in the vertical direction. So vectors can as well be written in column form. Can be written in column form. And we could bold this. We could make it bold. We can write vectors by bolding. So basically that's how we represent vectors. And we've seen that the moment you change the order of the letters, then those two vectors are no longer the same, they're different. If you were to just change the order from AB to BA, then in that case we shall say those vectors are opposite. Because you see, I'll have from A to B, then this other one will be from B to A. However, when you just interchange the letters, we shall realize that they will have the same magnitude. Because coming from A to B is the same distance as coming from B to A. So when you interchange the order of the letters, then those two vectors have the same magnitude, the same length, but they're in different directions. That's all about representation of vectors.